an equation of what? Conservation of moment. Now, if in case after collision the balls touch with each other, thereby moving in the same direction, now it means that after the collision the two balls got stuck and they move towards the same direction. It means that they are moving with same velocity. So automatically this equation will change. It will now become m1u1 plus what? m2u2 to equals to what? m1 plus m2. Now let's go to the elastic collision now. In this time, with the moment and the kinetic energy are conserved, we have your m1u1 plus m2u2, which will equal to your m1v1 plus your m2v2. Now, how do we also obtain the kinetic energy at each? So you can also use this to obtain your what? Kinetic energy. That's your what? Half. From there you have your half m1 u1 squared plus half m2 u2 squared, which will give you half m1 v1 squared plus what? Half m2 v2 squared. So this is what? The kinetic energy of what? Both momental equation. So that is being analyzed. So let's just do one or two examples before we go to before we go to the next topic. Yeah, let's start with the first one. Listen to that question. It said a body of mass 5 kg moving with a speed of 80 meters per second is suddenly hit by another body. Do you understand? In the same direction, thereby changing the speed of the former body to what? 6 meters per second. What is the impulse received by the first body? That first body has a mass m1, that's 50 kg. Abi? Now it's moving with an initial velocity of 80 meters per second. Abi? Now they now say it's being hit by another body moving in the same direction, thereby changing the speed of the former body to what? 60 meters per second. What the impulse received? Now that another body, the mass was not known, the velocity too is not what? Is not known. So from there now we are only calculating on this. Do you understand? So from there you have your m1u1 plus m2u2, which will give you 0. So from there you have 50.80 plus what? 60.u2. Are we getting it? So this is your m2. Your second velocity is now 60. So this is 0. Are we getting it now? So from there, or if you want to calculate your impulse, we know that impulse is given as force times t. Do you understand? So if we go through the equations given, you'll be able to actually dissolve that properly. So let's just put an asterisk there. Now the second one says that a body of mass 4 kg moving with the velocity of 10 meters per second collides with the stationary body, are you seeing it, of mass 6 kg. If the two bodies now moves together after collision, calculate the common velocity. This one too is very straightforward. Just write out your m2 u2 equals m1 v1 plus m2 v2. What do you do? The first mass is 4 kg. The second mass is 6 kg. Are we getting it? Now, the first velocity, are you seeing it? They say if the two bodies move together, the first velocity is 10 meters per second. Now, the second velocity, they said the body is on stationary. At the end of the day, we now discover that they both now move in same velocity. So if they move in same velocity, it means that the equation will become m1 u1 m2 u2 equals m1 plus m2 to give you same velocity. So what are we looking for? We are looking for the same velocity. What do? You just say m1 is 4, u1 is 10, plus m2 is what? 6, u2 is what? 0, to give you m1 is what? 4, m2 is what? 6. Are you seeing it? So this goes to be 0. So we have 40 equals 10v. So your common velocity will now be 40 divided by 10, which will give you what? 4 meters per second. So this is the common big velocity that is being written here. So if you go through the passages very well, the momentary values given very well, you'll be able to solve all those questions stated there. Now let's look at another question. Another question here is talk about that number 3. Number 3 says an object of mass 20 kg moving with a velocity of 3 makes a head collision with an object B of mass 10 kg moving with a velocity of 2 meters per second in the opposite direction. And I say if A and B sticks together after collision, calculate their common velocity in the same direction. Now, let's analyze this. The moving object, that's your M1. Your M1 is 20 kg. 20 kg. Now, the velocity of that M1, that's your U1. That's U1 is 3 meters per second. That's your U1. Now, we now say the second object, which is your M2, has a mass of 10 kg. The first one, remember, is 20 kg. Now, we now said moving with the velocity of 2 meters per second. So the U2 is 2 meters per second. Now, for you to write out the equation of momentum, what do? M1 U1 plus M2 U2 equals your what? M1 V1 plus what? M2 V2. So from there, since at the end of that question, they said calculate your common velocity in the same direction. So what do? M1 U1 plus M2 U2 equals M1 plus M2. That's the common velocity. So by the time you substitute all the value in, you have 20 times U1 is 3 plus 10 times U2 is what? 2 equals 20 plus 10 with this common velocity. So from there you have 60 plus 20 to give you 30 V. So if you add these two, you have 80 equals 30 V. So your common velocity will be 80 divided by 30 to give you 2.33 meters per second. Oh, no. 3 here is 2. Now we have 2 left. 3 and 20. We have 6 meters per second. So that would be our common velocity. So following this equation, normal equation of momentum, why are we using this? Because we said and after the collision, they moved with the same velocity. So that's why you use this equation. So from there, you obtain your what? V value. So let's proceed to the next topic. Machine is a device by means of what? Which work can be done more conveniently. It's just a means of which a force called effort. Do you understand? The force that is being applied is what we call your effort. The force you apply to your machine is what we call effort. Why? The point at which the force overcomes, the load force. Do you understand? So we said it's a means of which a force F called the what? Effort applied at the point can be used to overcome a force known as load. You understand? So your effort which you apply is your E. It's now used to overcome a load, the load force which is what? L. So the force you are using to be applying is what you call the F force. Now what you now want to use that force to carry is what we call the load. So at this junction now, we look at the terms used in the machine. We'll be looking at terms used in the machine. So we'll be looking at number 1, you have what we call mechanical advantage, you have what we call velocity ratio, and we have what we call efficiency of a machine. So after these three, we'll be able to look at the actual the breakdown of what machine actually is. Number 1, mechanical advantage. It is defined as a ratio of the load to effort. The ratio of the load to effort, that is. So number 1, we are looking at mechanical advantage. Load over effort. Load over effort. Now, if you look at it very well, mechanical advantage 2 does not have an SI unit. Why? Because load is in Newton, effort 2 is in Newton. So the SI unit is 0. Or you just say nil. Are we getting it? So at this junction now, we have the load over the effort. Now, we say, if you look at that diagram, we'll have a mechanism where here is your machine. Now, we have Y. You understand? We have load Y. Now, we have another load, another effort here, E. Are we getting it? So, here, the effort is going through an effort distance X. This is the load distance Y. So, let's say this is the load. Now, if we look at that mechanism where we say considering the general form of machine, it comprises of the load, effort, load distance, and the effort distance. So, therefore, the mechanical advantage will now be given as well, load over effort. Now, we also have what we call velocity ratio. Velocity ratio is just the inverse of the distances of the above formula. That is, velocity ratio is the what? Effort distance. Effort distance over what? Load distance. Effort distance over what? Load distance. That's your what? Velocity ratio. Effort distance over what? Load distance. Now, if you go down, you will see there's what we call efficiency of a machine. What's the efficiency of a machine? It is defined as the ratio of the work done by the machine to the total work input into the machine. That is the ratio of the work output. You understand? That's what I meant to write there. We have the efficiency. You know, this is our number 2. Now the number 3 is efficiency. Efficiency is work output over what? Work input times 100 over 1. Work output, you know, the work output is what is actually coming out, and that's the load. Share it. Load times that load distance over work input, what you are applying, that's the effort times what? Effort distance. So by the time you restructure the equation, you have something like this. Now, by the time you restructure it, you are going to have times load distance over what? Effort distance. Now, load over effort is, remember we said it's mechanical advantage. So, mechanical advantage